We are going to move to the next speaker with Pierre Moriniere from La Rochelle. Pierre is a biologist. He's working in La Rochelle, France. It is located in the western part of France. La Rochelle Aquarium is a very nice aquarium to pay a visit to. Our name is very nice. La Rochelle is very nice also. You have to go to La Rochelle. Pierre has a PhD of oceanography from the University of Brest, and as he told me yesterday, he is a very, very good specialist of the Dover sole, the flatfish, this delicate food fish. Before working for the team Coutan at La Rochelle, Pierre had worked for his own company, trading fishes and crustaceans at the international scale, so he has a private experience. He integrated La Rochelle Aquarium some 20 years ago. He is a pillar of La Rochelle Aquarium too. And he had participated actively to the elaboration and construction of the new aquarium that was inaugurated 10 years ago? 8 years?
Yes.
Yeah, okay. Yesterday Pierre gave me a secret.
I'm afraid.
Yes, I'm going to give a secret of you. You get fond of sea and the creatures living in the sea by sailing with your family when you were a child. Mm-hmm. And it's sailing on the sea that you discovered that something was to be discovered underneath. And so it's nice to see you today to make this presentation. So we have the pleasure to listen to you now.
Thank you, Pierre. Good morning. This work has been done with the collaboration and participation of the staff of the aquarium, and also with a great interest for breeding program of Pascal Coutan. So that's my plan. Breeding wild animals in captivity is one of the major ambition and expectation of our job. It's also a proof of the animal well-being. Captivity must meet the animal's principal requirement and ensure their major vital functions such as breeding. Recovering eggs in a good state of health and breeding young animals, especially fishes, requires technical means and time. At La Rochelle, at the Aquarium of La Rochelle, we work at breeding animals. Each time we have reproduction, and we have already bred several species of amphiprion, for example. One of our major motivation to develop our expertise in this domain is to reduce the takings in the natural environment and to get fishes acclimated to inert food and able to live in an aquarium. Anisotremus virginicus is a part of the Emulidae family and is better known as porkfish or Atlantic porkfish. They live in a tropical area from the Atlantic West, from the Caribbean, Florida to Brazil in 25 degrees water. The name of porkfish has been given because the young can do ensure the function of cleaner fish with the larger fishes. Juveniles present different patterns than the adults until they are 1 year old. Adults can reach the size of 30 centimeters for males and 25 centimeters for female, and sexual maturity is reached at 24 centimeters. It's a solitary fish, but it can also live in small groups, and it uses sounds to communicate with its fellows. It's a carnivorous fish which feeds with various invertebrates. And the breeding period has been noticed in the wild from April to December, and sometimes on the open sea, sometimes on the coast. Anisotremus virginicus isn't recorded on the vulnerable species list of the IUCN. In 2000, at the time of the new aquarium La Rochelle opening, we purchased a pack of Anisotremus virginicus from Florida. And in 2002, a group have been put in quarantine, and we started to observe the first spawning in 2004, still in quarantine. This spawning occurred in a group of 6 individuals, but we couldn't identify the breeders. We gradually lost the other members of the group to keep only one couple, which has continued to reproduce. Each year, the reproductive couple was isolated during 3 months in the reproducing tank and then come back to the exhibit tank. Indeed, we didn't observe spawn in the community aquarium. In 2008, the couple was isolated during 8 months. Both individuals was 28 centimeters long for 500 grams. The aquarium of the breeders is a circular pond with 2 meters in diameter, 1 meter height, and a volume of 3 cubic meters. It is equipped with a humid filter, gravity feed, with mechanical and biological filtration. It is this an average temperature of 26 degrees, and lighting is made during 13 hours. Moreover, the room has a natural source of light. Spawns are nocturnal and occur about 2 hours after light extinction, around 10 o'clock in the evening. And then the hatching occurs in the afternoon of the days after, between 12 and 4 o'clock p.m. Time incubation is between 14 and 18 hours. The pelagic eggs are collected in the morning thanks to a sieve installed on the water exit of the tank. So the pelagic eggs are collected in the morning, and the eggs are 3.6 millimeter in diameter. Non-inseminated eggs are sinking and pulled away from inseminated eggs by settling. The average insemination rate is 80%. And the spawns are distributed on 3 days running. And during the studying period, 14 spawning periods have spaced out regularly from April to July on an average of every 10 days. Eggs are counted and put in incubation in the breeding larval tank. The fecundity is of 76 per gram eggs per gram of female, which represent 40,000 eggs for our 500 grams female. From 2004 to 2008, the couple was transferred for the aquarium to the reproducing tank only 3 months. For the need of our study, this period has been extended to 8 months, and the female spawned 42 times until it died. The necropsy revealed that the liver was atrophied, which is a sign of an exhaustion of the lipid reserves of the female. Rearing. Larval rearing is made in a cylinder conical tank of 60 or 120 liters with black walls. The fitting includes 6 tanks separated by opaque walls in order to give them their proper lighting. A fluorescent lighting is placed on the top of each tank and is controlled by a time switch to regulate the length and the intensity of the light. A non-stop lighting has been compared with a lighting with a nocturnal light reduced of 10% every 2 days, from 190 to 50 lux, or from 85 lux to 24 lux. Each tank is connected to a life support system, including biological, mechanical filtering, sterilization, temperature regulation, and aeration. Temperature is set to 26 degrees, and the renewable rate is 100% per hour. A surface separator feed with air allows the elimination of the upper greasy films. And most of these techniques come from Sparus aurata aquaculture technology, well developed by our president Nadia in her thesis. The feeding from day 2 to day 15, the feeding is made with Rotifer Brachionus plicatilis, fed with chlorella paste, enriched with DHA and vitamin B. And before distribution, rotifers are enriched with protein Selco plus, and rotifers are shared out 5 times a day at a concentration of 10 to 15 rotifers per milliliter of breeding. From day 10 to day 20, the feeding is made of 24 hours Artemia nauplii AF, which are very small size nauplii with a very high level of fatty acid. And from day 15 to day 30, with a transitional period between day 15 and 20, feeding is made with Artemia nauplii enriched with 24 hours with the Easy Super Selco or red pepper paste. We did 42 experiments, and the results of survival were very different, from less of 1% for 17, between 1 and 5% for 19, and in 3 cases between 5 to 10%, and in 3 cases from 10 to 30%. The best results were obtained with a stocking density of 50 to 100 larvae per liter. Lighting, the first positive result have been reached in 2008 with a 24-hour lighting, which seems to allow a best food taking. A progressive reduction of the nocturnal lighting of 10% every 2 days seems to give encouraging results. Enriching rotifers and nauplii on 2 products didn't show significant difference. We finally produced 2,000 animals, which have been either exchanged with other aquariums or either sold. They also allowed us to have 400 individuals school in the shark tank at the Aquarium La Rochelle. Despite of these encouraging results, we still have improvement to do. The irregularity of the survival results shows that the rearing parameters don't fit enough the requirements of the species. And we are planning to isolate some individuals in order to check if the second generation is ready to reproduce and to begin a new rearing test. It's evident that the quantities could be very much higher, quantities of fish we can produce. And one couple could produce enough fish for every aquarium all Europe, or even the world, when we see the fecundity of such a fish in comparison with eagle ray, for example. So thank you for your attention.
Any questions to Pierre about this very good presentation? And a lot of aquarium in Europe got benefit from your fishes. I think you sent to 10, 12 aquarium in Europe. Yes? I have one question, Pierre. Porkfish is a food fish in the Caribbean. It could be also, this technique could be applied for aquaculture?
Oh, maybe, yes. I think it's a comestible fish, yes.
Edible?
I didn't try.
You should. Okay. Is there any question to Pierre? No question? Okay. Very nice. Thank you, Pierre.
Thank you.